Hi. Hey, Bellum. How's it going? Alright. Let's get this stream started. Pretty good. Had lunch with a team from my old company, which is interesting. Ah, very cool. Because you're getting back your old company and stuff. Old bank. Alright. So, goals for today. Oh, I gotta show you guys this. I wonder how great of a quality this is gonna be. I modified some of my stream settings, so hopefully this works. Someone else is leaving that company and dividing me. Alright. I upgraded my stream settings, so hopefully it should be like 1080p. I'm not sure if it will, but should be really quality. Alright. You guys need to see this. Give me a second. Alright. There's like a lack of light here, but so this thing finished printing yesterday, and I think it's pretty good. It hasn't always been 1080p. I think it's always been 720 by p60. I think. I don't know. Maybe. I just changed it in the settings, so hopefully it works now. So this camera should be in the best quality possible. Now I'm gonna go look and see if that's the case. Yeah, it looks pretty good. Okay. No, Bellum. See, that's how I knew it wasn't 1080p, because that channel's video was only 720p 60 at the highest, and I was like, huh. When did you become an avid picnicker? I don't know. But so I removed the top. It's a little bit of a tight fit, so I think I'll have to like give the top and bottom some more tolerances. Maybe the top, because the balls is perfect. I don't know if you guys can see this. You guys probably can't. Let's see if I can angle it to be more visible. The back here has these little pegs that the battery is going to slide into. And these pegs are tipped with conductive paint, so that when the battery slides in, let me see how I can make this like visible to the camera. Like this. Like this, right? This basically just slides in perfectly. And like no tolerance errors, which was impressive, because I usually get those. Electronics go on the back. This cap goes on. And then this goes on top. And everything like perfectly fits. Like I got the tolerances extremely right. What type of suppression does it have for the battery? Fire suppression. Good question. Eventually I'm going to make this out of resin, so that it's not going to be flammable, or like melt. And the school has a giant resin printer I can make these out of, instead of plastic. And the breakable fire suppression is that if this battery expands, this entire shell is just going to break apart. You weren't expecting a real answer. No, I thought of this, because like these things explode. Hi, Bobby. So this works, which I'm glad it does. I haven't screwed anything together because I was just doing a tolerance test, but because this worked, I can finally like look at this. It goes like straight in. Look at that tolerance. Probably from the top. I have to figure out a way to do this, like to demonstrate this working, like when on camera. Do they make like fire retardant filament? I wonder. Maybe. I know they make like wood infused filaments and stuff like that. Oh yeah. One more thing. So when I print the solenoid things, oh, it finished printing. I literally just ripped this out of the printer. Let's see. I have to break the supports out. Like, about that YouTube channel, for those of you who don't know what's going on, I was doing some Googling of my channel for one of my friends to help her with her a business final, and I came across this YouTube channel, which had my face on it as the icon, and was uploading VODs from the channel. And I was like, huh, that's interesting. I didn't approve of this. And it was just very weird, I would say. And so I went ahead and tried to put a request to get rid of those videos. Because although it was pretty funny, it was copyright infringement or impersonation. And we can't have that here. Dude, the video has 7.3k views now. I'm not sure if those views are botted or if they're legit, but 7.3k views. Alright. Just rip this out. Anyways, I contacted YouTube to try to get it removed, but since I don't have the YouTube support thing, you get a 10k subscribers or something, I don't know if they'll actually take it down. I did link it to this Twitch channel though. I do have a YouTube channel. It's not called Fafa. But I don't really use that one yet. I plan to use it in the future, but right now Twitch is just an easier way for me to stream because I don't have time to edit videos. You try to report it too? Oh, thank you, Bella. That's very helpful. Alright, so this is the finished solenoid holder. Now for the moment of truth, to see if this thing actually fits inside. So, my plan for this was to... You're gonna give it one view. Why are you... Nasty, why are you supporting this, the people who are stealing my videos? We could just visit here. Imagine if they ripped this vid talking about them. That'd be really funny. That'd be really funny. I think I made that bottom hole a little bit too small. I think I made it a bit too small. Yeah. Alright, that's fine. That's not fine. I need to put this through somehow. Yeah, that hole in the bottom is really small. I wonder if I can drill it out. It's weird because that channel was created in 2014, so I think it's a hack channel they turned into a VOD. Kind of like how they used hack verified Twitter accounts for phishing. Maybe. I'm saying it's not me. Okay, I expanded the hole a bit. It's good for one wire. Don't know if it'll fit the other. Are you sure you don't love to cook and picnic? I've cooked once. I've taken one cooking class at this community center thing. I think I set a pot on fire and they kicked me out. Oh. Should tell you a story about that actually. I used to do community volunteer work. And I would serve, I think it was at the elderly center near my house. And I remember they told me to go out and pour some water for the guests. and they gave me this huge looking pitcher of water. And this pitcher of water was very weirdly shaped. They have the bio, right? Yeah, they did. I mean, I'm not technically a technology engineer, but, you know, close enough, right? Anyways, so they gave me this really large pitcher of water and told me to go ahead and fill it up. Or fill up the, you know, water glasses and whatnot, like you normally would for serving, right? And so I went ahead and did that. But the exception was that these pitchers of waters were really heavy, and I was like 12. And plus, the mouth of the pitcher was shaped in such a way that when you started pouring the water, it would like go along the side of the pitcher instead of like in a nice arc into the water. I don't know if that makes sense. Like if I poured some water out from like a cup, it would run down the side of the cup instead of like into the glass. So anyways, that's the story of how I poured an entire pitcher of water on the ground instead of in the cup. Because I was pouring, I was like, if I pour faster, it's going to go into the cup. But then I started pouring the water. It went along the side of the pitcher, onto the floor. I kept pouring harder, and just the water, the physics of water just didn't work that day. So all of the water went on the ground instead of the pitcher. And I had to go back and get another pitcher of water and clean up the mess. But I think that was a interesting experience to say the least. And this wire is not going in. What? Fish. Yeah, I need to make this hole a lot larger. Or I can just go ahead and try to do this. I don't think that's gonna work though. And anyways, you know what, I'm just gonna stuff it through the center hole. Screw it! Screw it. Through the center hole it goes. I just need to test this tolerance to see if it's right. Okay. PLA against aluminum. Let's see if I got the tolerances right. And I did not get it right. It's close, but it's not right. I think the sides are okay. The sides are okay, but I think the wire being on the bottom, I didn't account for this wire being there. And because the wire being there, it doesn't fit. It's a cool looking little structure though, so that means I have to change two things. I have to change the hole in the back, and I also have to make the bottom wider so it fits the wire. Analysis. But, you know, this works, so I'm very happy. I just need to screw everything in and just make sure it works in whole. With the top piece, actually, so like the full structure of this battery cage. Let me put it backwards. Okay. The full structure of this battery cage comes with it comes with the AR tag, so it's kind of like this, right? That's how it's going to be on the vending machine. And then, so the battery with the top cover on, the issue with this is, I don't know if it's an actual issue or if it's going to, like, it's something I'm going to deal with in the future. But there's a little bit of a tolerance issue, which I didn't account for. If you hear the sound when I'm taking it out and putting it in with the top on, it's this very, grindy noise. It's like, it doesn't take that much force to put in, let me tell you that. But it's still like grinding against top and bottom. And then, so if you're like just putting it in from like the back here, like you can just slide it in. It's a very tight fit. Just put oil. Just put lots of oil. Yeah, that might be it. But this part works really well. This feature of it where you like put this thing and it locks into place, that works really well. It's not coming out. Oil to help fuel the fire. Yeah, exactly. Okay. Anyways, So that's a success. This thing is just going to turn into a huge fireball, isn't it? Okay. Anyways, so I'm going to go ahead and try to cat up the wheels today. That's my goal. And try to get some of the rotating chamber parts sorted out. By tomorrow, I want to get at least the whole thing done, the whole chamber completed, and then I'm going to make some animations of it, hopefully, if I know how to do so. So animations are cool. Okay. So real quick, we went ahead and did some... Let me update the milestones real fast. Okay. So we tested the solenoid support. I'm not going to say if it's a success or a fail, but we tested it, so I'm going to check that. We also tested the slotting mechanism, so it's also done. And now we're on to modular support. Now, I'll have you guys know I gave this a lot of thought last night on how I should actually add wheels to this thing. Because, I'm sure I agree, I'm going to balance the music out because you can't hear the music on here. Okay, I think that should be better. Yeah, so, modular support. How do I add wheels to this thing? Now, back when I did the Hyperloop project, I had a structure called the fork. And the fork was this little 3D printed wheel bearing mount that I used in a lot of examples, because I think it was a good example of 3D printed holders, although some might disagree. I think I might do something similar to that in this design, where I'm going to remove this bigger wheel part. This bearing is going to be accurate, but I have to match the diameter of this outer wheel. It's going to be around 22.3 millimeters. Okay. Anyways, I'm getting ahead of myself. I'm going to go ahead and change what I need to change first, which is going to be this part of it. And then we're going to go ahead and modify the other stuff. So solenoid holder 1, if I activate this, that's the wrong one. Solenoid stuff. Solenoid holder. I have to find the sketch in which I modified that. And there's a lot of them, so it's going to take a while. Alright, so which sketch was it? Out of my 99 sketches, which sketch was it? Alright. I think it was sketch 93. So this is the first culprit. No, this wasn't it. Sketch 94. Some of these sketches were questionable. No, because it has to be extruded from the bottom, huh? Was this one? Okay. So this one, I think we have to extrude this down a little more, maybe by like 1.5 millimeters. By 26 millimeters, just to give room for that that wire. Let's measure this piece real quick. This wire has some space. So in addition to the back part, yeah, it's exactly 1.5 millimeters. So theoretically, this should be enough if given the other tolerance as well. Okay, and then I need to enlarge this to maybe 10 millimeters. Yeah, it's bigger than the 7.5 millimeter. Because this is a wire, this should be enough to house both of them. Because both wires next to each other is about... about 4 millimeters. So yeah, that'll give it some room. Okay, so that was sketch 84, 80. Which sketch was that? No, it was like 85, 6, 7, 8. 90. So then this extrusion okay, I have to turn off the rest. Chassis chamber. Okay. So that should give it enough room. And then this back piece can stay the same, because it doesn't really matter. Alright. So that's fixed. It should fix for the other one as well, I think. Because they're just the same components. Yep. Alright. That's good. Now let's move on to the other part of all this, which is the wheels. Okay, I'm gonna open up a notepad, and I'm gonna save this measurement. Should be, yeah. I know I say should be, but I always say that. Okay, measuring this outer piece gives you a diameter of 22.3 millimeters. Which is pretty exact, I think. So, in the modular section, I'm going to go ahead and delete the support wheel model from here. Delete. Yeah. Don't yell at me, because the rigid group is not going to be a thing anymore. But if I delete it, it won't complain, so that's what we're going to do. Okay, create a plane here, create a sketch, and then I'm going to go ahead and create a circle from the center point of this, and this is going to be 22.30 millimeters. Which is going to look like that. And then what I'm going to do is I'm going to create a center rectangle. That's going to go ahead and... I really don't like the black chassis. Can I get rid of it? It's throwing me off. Okay, there we go. Now I'm just left with like all the external parts. Okay, so this is going to be a, let's say, 28 by 64. I'm just guessing. So I want this to be the same. I want this to be maybe like 55. Because then I'm going to go ahead and put a circle here and here. And I wonder if this is too large. Oh, that is exactly right. Okay. I wanted it to be exactly smaller than the top piece so that it can like swivel around. Okay, great. The plan is in action. The plan is in action, my friends. Alright, so then we go ahead and just extrude this entire thing, except for the centerpiece, up. And I think this bearing is exactly 7 millimeters, so we'll go 7 millimeters. Right. Okay. So then this piece is pretty much done. If I print this piece out, I can just hammer a bearing into it, like using a heavy screwdriver and just whack it in. And then I can put the bearing on top. And I need the cap, because the cap is going to hold it in place. Alright, so let me get my cap dimensions from Hyperloop. What do you mean ECE student moment? Hammer the bearing in. That's the best way to install a bearing. What are you talking about? You don't need fancy O-rings like Kandarsa say. You just need force, brute force. Like I'll tell you. Like I brute force tested this dimension, and I'm like 90% certain it's accurate. That should tell you like the extent of my testing procedures, or what it's like. Okay, so the center axle, which should be 8.04. Right. Percussive alignment, exactly. The Yoshi eats cookies gets it. I used to be a percussionist, I would know. Alright, so it's in here. I need the side wheel cap. And this thing. Okay, the inside diameter of this ring. Oh, jeez. Okay, hold on. I can't isolate this piece. Can I, like... I can't move it because it's jointed. Okay. Plan B. What are the possible sources of errors? Don't know. Sounds like a software error. I'm gonna use that. I'm gonna use that if it comes to it. Describe the possible sources of error during your experiment. Well, maybe the fact that I hammered the bearing in instead of using like precision tools is a cause. 0.04 millimeters. Okay, I saved this STL somewhere. I'm gonna go ahead and put it in. Side wheel cap. I'm gonna do the cap a little bit more intelligent this time, rather than just putting it in. Because, like, the Hyperloop pod was made primarily through a combination of screws and force. Force mainly for the smaller components, really. Is it replicable? Probably not. Does it look good? Yeah. That we'll have to, like, figure out later. Okay. Side wheel cap. Oh, it's in inches. Diameter 8.128. Cool. Well, I'm gonna go ahead and just do a little bit of this action. And then the outer diameter of that thing was 12.7. Okay. Now, theoretically, if I extrude this up, by 7, it'll be exactly correct. So I'm going to extrude it by 6.5 millimeters. Close enough. Right? Close enough. And because they left absolutely zero room for error, I'm going to need to move that down. Like by 1 millimeter. Okay. And then expose the sketch again. So many sketches, I'm lagging. You know what? Just kidding. You guys didn't see anything. Okay, I wonder what the back part of it is. Two. 2.54 millimeters. Right, that's like 0.1 inch. Sure. Okay. It's looking like a pretty good cap so far to prevent it from moving. And I'm going to go ahead and create a hole in it. And I'm going to nail a M3 screw down the middle. We need a new PC fund. I think I need like an actual PC, not a gaming laptop. So investment for the future. Okay. This is gonna be a, no, just a hole. Wait, if it's 2.54 millimeters... Imagine the PC build stream. Oh god. It's gonna be even worse than the Ender 3 build stream. It's like I'm gonna put the CPU in, it's gonna start smoking, and I'm gonna be like, I wonder what's wrong. I'm gonna extend it by 4 millimeters down, just because I can put the hole in correctly. Cup's gonna be 6, this is gonna be 2. Maybe 3.5. Okay. This cap's gonna be horrendous to print. I'm probably gonna have to belty print this, because my regular printer's not gonna be liking this shape on the bottom of the cap. Okay. So what is this piece? Wheel holder. Oh, okay. So on wheel holder, here, I'm going to go ahead and nail a hole through the center of this piece. This one's going to be threaded. I'm doing this a little bit more intelligently this time. So 2 plus 4 is 6. I can do math. Cool. Okay. This isn't a ring, but close enough. So, modular ring. Okay. Where's the cap? Oh, that's the cap. Right. Of course. Okay, so theoretically, when we print this out, this whole thing should be able to swivel based on the bearing. And if it doesn't crash into the piece below it because of this misaligned screws. Great. So now I have to go ahead and put the wheels on. Now the wheel design is going to be screwed onto the edges of that, I believe. So let me go ahead and make a sketch on here. So this piece is going to be called the modified fork. This is not going to print one piece, is it? I'll try to. Let's see if it's going to be able to print one piece. So I'm going to put 15 here. Okay. Do you think 15 is strong enough? But this is millimeters. Maybe 20. I'll do 20. I have to make something strong enough so that it's able to handle a large... Basically, the weight of the entire battery, which is like half a kilogram. Like, resting on it. And then duplicate it again. Alright, how low will this go? Let's see. Do I really want circles for this? No, I don't want circles for this. I want something maybe flat. Flatter, yes. Flatter would be good. Maybe something like this, like 22.5 by 6. Maybe like 10, not 6. Yeah, something like that. And then you can just extrude this portion in the middle. There we go. Now extrude it down like maybe 50. Maybe that's overkill. These wheels aren't that large, right? Um, 35.56. These wheels aren't that large. This is fine. Okay. And then, they can fit 3 wheels in here. Let's see. So I bring one of these models, and then I rotate this 90 degrees. Why is the pivot so out there? Okay, let's see. That is definitely real close. Oh, that was definitely not anywhere near where I thought it was going to be. Yeah, that'll work. As long as like the cap doesn't come tumbling down, it'll work fine. So basically the idea is that, wait a second. This is in the wrong direction. Because, hold on. Hold on. It's in the wrong direction, actually. This whole thing needs to be rotated, like, to the right. The physics of... no. It's not gonna like the physics of that if it's, like, rotated 90 degrees. Let me test that. Okay, so I don't believe the modular... Because this whole thing has to be rotated 90 degrees, huh? Okay, modular ring. I'm going to go ahead and move copy. So you have to be like this. If I put the battery chassis back on here. Chamber. See, this is going to stick out, which I was scared of happening, actually. Why is that not 90 degrees? What? Modular ring. Okay, physics lesson here. Would this support the weight of the battery? No, unless I put it up here as well. Or in the center. If I put it in the center, it'll work. Okay, so I'll have one on the back. I'll have one module on the back, and then one module in the center, and then one on the very end. That way it will be supported by 3 points of contact. That means there will be 6 wheels for one of these things. Come on, let me rotate this nicely, please. Okay, so it's kind of gonna look like this. Okay, I want to make this so it's like smaller, so it's not sticking out like this. So for that, I'm gonna have to make this smaller. The distance from the center of this design to the edge is 33.92, which means this is going to have to be 33.92 minus 14 divided by 2. 33.92 minus 14. This is already 30. Come on. This thing. 33.92. 19.92. I think that's how small it has to be. Yeah. It's only big enough for one wheel. Actually, it can be slightly bigger. I think I did my math wrong. Let's set it at 25. See what happens. Oh, okay. I did my math very wrong. Maybe it is 33.92. 34. 34 is too much. Screw math. Guess a check. Yeah, 28. 28's almost there. I think I can go to 30. I'll do 30. 30 is too much. Okay. I guess it's 29.5, and then I think if you're careful enough, you can probably... If you're careful enough, you can probably fit 2 wheels in there, but you're going to have to offset those pillars. Yeah. Say 17. I'll go 17.5. Fail to resolve. By 10. Yes, Bum. 2 whole wheels. Ho ho! Oh no. I seem to have forgotten to turn this 90 degrees before I moved it. How do I solve this? Huh. Well, so shift the whole thing. Nine. Yep, there you go. Soft fix. And anyone who's gonna look at this in the future is gonna be really confused. Nobody tell them. Nobody tell them what I did. Alright, alright. Where did my support wheel go? Okay, so there's gonna be one wheel here. Here. Okay. Let me just unlink this first. Oh, goodness. You see a long load time, you fear for the worst. Okay. Copy paste this. Wait, what? Oh, this is... It's not letting me move this inside modular. There we go. Okay, so this modular module is just like one of these rotating thingies. Probably gonna eventually have to stuff it inside another one. Okay. So these wheels are great and all, but they are better when they're spaced out like this. Well, they're definitely not spaced out enough. Before I forget, I still need to joint that piece. Yeah. I need to joint a lot of things. What is this thing called? Wheel holder? Okay, and I need to joint that piece. Modular cap. Where's the... What? Oh, it's inside of wheel holder, isn't it? It is. Okay, everything's like properly jointed now, which means I can start messing with the wheels. Of course, the pivot's like all the way. Why is the default pivot all the way up there? close enough. That's close enough. I'll deal with the exact measurements later. Okay, so the idea is just to make some sort of structure that, like, maybe like drill a hole in here, and then put like a central axis through with spacers in between. Yeah, that's probably it. How high is this from the bottom? I'll decide the height later. I'll just decide the height now. Okay, so if I project this onto the thing and I measure it, about 8 millimeters. I'll go 7.5 millimeters just because that was the standard. Doesn't really matter. Hold on, 1 second. I just realized I was muted this entire time. Nice. My mic's still... Yeah, I realized. I was like, these bars on the left here are moving less than usual. I wonder what's wrong. I was back for a while. Just didn't realize it. 22.5. Oh, hey, that's the thing. Okay. And then I'll just mirror the entire thing across this line. That's slightly better. Now, I don't remember exactly how far down I have to do this thing. I think it was like 40, I think. Maybe. Was it 40? Yeah, it looks like 40. Okay, and then I make a circle, or a point rather, in the center of this, 9 millimeters, and then 7.5 millimeters down. Okay, and then I hide these and extrude all the way through. Nice. Memory test. Success. Ah! Scary extrusion. Okay. So that's where the pole's gonna go. Now, I imagine that on one side of this, or on either side of this, we'll have to see, there's going to be some piece that's going to be screwed on, so the assembly isn't going to be all press fit. And I think I have to take a precaution of that now. But before I do that, let me just go ahead and apply some fillets, because we love our fillets, to the top and the bottom edges here. It's a small one. And then also all the way around this top area, because if I don't do this, I already know that this is gonna fall off, because these poles are not screwed on in any way, shape, or form. Yeah, 1 millimeter is fine. Okay. And also apply some to the end here too. Actually, I'm gonna have this even higher, at 10 millimeters. Reason being, I want to put screws in this later. Okay. Looks good. I'm going to go ahead and apply a small fillet to the edges here. Just for fun. Now I won't stab myself when handling this thing. Nice. Okay. So the way this is going to work is that I'm going to have a central axis catted through here, and I'm going to have a little piece on the end of it that you screw onto an end. That way it stays into place. And then it's going to go through the center. It's going to go through both wheels. There's going to be there's going to be 3 spacers in the middle, I think. You'll find a way to stab yourself with it. It's probably right. So I'm going to go ahead and find out the exact distance between these 2 points. And we're going to do a little bit of math. So this is 25 millimeters. 25 millimeters. And then from left to right, So it's going to be a 25 millimeter gap. And then from left to right, we're going to have a question mark. Let's say X. And then we're going to have the wheel, in which the wheel's thickness is 7 millimeters. And then we're going to have X again. And then 7 millimeters again. And then X. So basically, 3x plus 14 millimeters is going to equal 25 millimeters. 3x equals 25 minus 14. Oh, goodness. Which is 11. I know how to do math. That means x is going to be 11 divided by 3, which is going to be 3.67, I think. Anything subtracted by 25 and 11 just gives me PTSD. I missed half a point on my final exam for my stats class because they didn't know how to subtract these simple numbers. I think I said like 25 minus 9 was 16 instead of 14. Anyways, so it's 3.67 millimeters. This is going to be our spacer length. And then I'm going to go ahead and downgrade this to 3.6 because it's going to be a little bit less. Alright. Next, I'm going to go ahead and chamfer the outer edges of these holes. Just because we're sticking stuff through them. Makes it a little bit easier if there is an outer lining to it. Okay. And then I'm going to go ahead and drill some holes into the front here. Okay. Make a center rectangle. I'm going to do like maybe 12 by 12? No, maybe like 15 by 15. No, 12 by 12 is right. Okay. I'm also going to create a mirror plane between these two edges. A mid-plane. It already has my settings. Alright, and then I mirror. Okay. So then, next I'm going to have to make a thingy to attach itself onto this plane. So offset plane, about 10 millimeters back. Oh, where'd it go? There it is. Okay. So this little bar in the middle is going to be 8.4 millimeters. 8.04 millimeters. And then there's going to be a big center rectangle. Or maybe a big circle. No, a big rectangle. It's going to be like 18 by 18, sure. Yeah. Okay. So then we're going to extrude this. Downwards in this direction. Let me give it like 5 millimeters? No, 4 millimeters. Okay. And then the distance between this brick, the outer two bricks, I think it's 45. Yeah. So I'm going to put it a little bit more in the other direction just to give it some room. I'm going to go 48. I'm going to go ahead and open that up sketch. I'm on to sketch 110 now. So including the 4 there, 48 plus 4 is 52. So then the sketch is going to be, take the center one, extrude it 48 back, no, 52 back, and then join. And then also get rid of the solenoid caps on the support wheels. Straight through. Very nice. Okay. And then get rid of the sketch. Okay. So now we're left with that. I think I'm also going to have to extrude for this one these 4 holes. Okay. So at least it looks like that. And then I'm going to go ahead and put the special holes in here. These holes are the countersunk, simple. Go 4 through 6 to then 5. Oh yeah, it's just barely enough. I wonder if I can just get rid of that outer area by filleting. That's gonna cut it close. Just a tiny bit. I don't actually think this is gonna print. That's why I'm doing this. Or I wonder if I can just get it to yeah, no, this will be probably fine. I'm gonna extend it to 20 by 20. Okay, that's slightly better. Okay, so this is gonna be screwed in. I'm gonna add a little emblem in the center just because it looks better. Just a casual centroid. Too many sketches? I agree. I don't know. It looks fine. Like the outer circle gives it shape. I'll add one more. Yeah. Okay. And then I will go ahead and make this a body because it's not a body. And then put it all the way through. Then I need to replicate this model on the other side, I think. But this time without the pole in the middle. Yeah. Okay. And all the way in. $48. Alright. So that'll screw itself into the bottom there, and I need another piece over here, this time with a 3mm like cap. This time the center won't be just like this diagram, the center will be a screw hole. Okay, so offset plane. And then a center rectangle of 20 by 20 again. Extrude this 4 by 3. And then extrude I have to open my sketches folder again. Here we go. It's so large. And then extrude it back by 3 more. Wait, so I have a 3x6 screw. And also a 3x10 screw. So 3x10 would be 6. There. Do I have 3x8? I should have 3x8. It's 3x8. I don't know if I have 3x8. Let me check. I have 3x8. So if it's 3x8, then it's 4 down, 4 up, which means this is going to be right. Okay. I have the sketch now. Yeah, nice little round peg there. I'm going to go ahead and make a 1mm gap between that. Oh, 9. Because I know for sure that tolerances exist. Okay, then I'm gonna go ahead and project this back sketch onto there. So 1, 2, 3, 4, and also 5. Okay, finish the sketch, and then I'm gonna make a hole. So these back 4 holes are going to be the special ones, the 462 3.5s. And then the center hole, get back your sketch, is going to be the same thing, only this time it's going to go down 3. The others go down 6, I believe. Wow, look at this. Look at this dimension, D949. Okay. Now I can hide the sketch. Then I just fillet the corners. One, 2, 3, 4, 2.5. Okay. Now this piece is pretty much done already. It's a little thicker than the other one, but it's for a reason. Oh, and then for this piece I have to go ahead and make a drill-sized hole on this side too. Actually, if I want it to be mirrored... Wait, I want it to be mirrored, right? So the same size on the left as on the right. 4 millimeters. Hold on. This sketch is gone. Where was the sketch where I extruded this thing? Okay, bring this back by 3. Okay, and then on this extrusion, I'll just extrude this part out. Make it a solid block. Okay. Alright, we're good. Ignore the horrible catting. Center point, finish sketch, hole, and then need to make it threaded, simple, anti-metric M, 3.0, 3, 6, no, simple, 3. Right, so then this is going to be 4, 3 millimeters deep, 2, 3, no, 4 millimeters deep. And this size is going to be M3/6 too. Okay, cool. Goodness. Okay. This is going to be the modular axis cap. Okay, and this is going to go in modular, and then I'm going to joint this piece, this piece. Alright. There we go. Everything screws into each other. There's a lot of screws being used. And now we just put the wheels on. Where'd the wheels go? Okay. So then these wheels, I'm gonna have to joint them. Just make sure they're a rigid group. Delete this one. Oh, no. Okay. Move. Joint. Wait, did that just move it? It did. Oh my goodness. Okay. Ground this first. It's not movable. This thing is. Okay, then joint this to this. Okay, one's down. Now for the other one. Joint this, this. Okay, now I just gotta space this out correctly. So this is negative 5.5, and I want it to be, so what's it again? 3.6 millimeters. So 5.5, 5 minus 3.6 was 1.9. Okay. And the other one, it's 5.5 again, so just 1.9 in the other direction. Wait, why did that one move? Wait, hold on. I think I'm gonna make the caps first, and then deal with these wheels. So the caps are pretty easy. Easy as you can get anyways. I'm gonna make them fit all the way through, so then they're just gonna be 9, and the cap thickness is gonna be 12, I think. Right, they're gonna be like this. $12.75 almost. Okay. So they're gonna be a loose fit, pretty much. And I have to just have to extrude this back piece 1.9. No, 3.6. I'm gonna make the interior 8.5 just because I know that 0.5 millimeter of tolerance is usually all these things need. Okay. This is gonna be a mod spacer. I'll make a component from it, put it inside modular, and then like copy it a bunch of times. And then I'm gonna go ahead and place this, I'm gonna joint this piece to this piece. Okay. And then I'm gonna joint the wheels. So this piece to this piece. Okay. And then this piece to this piece. Whoops. That should be flipped. Yeah. And then joint this piece, this piece. And then finally, this piece to this piece. There's going to be a little bit of space left, but that's okay. That's for tolerance reasons. I can just go ahead and scooch this up to like 0.5. Maybe like 6, 7. There you go. Okay, now it looks less obvious. Spacing. Alright. And with that, I think that's one modular piece done. So, these are going to be the wheels. Hopefully that, this isn't too close. And I'm going to have to shave it down. Hopefully. What's the distance between that? I wonder. 1.22 millimeters. Wow, that is close. That is much closer than I anticipated. Where does the hot glue go? I'm screwing everything down, so there's no hot glue, actually. I want to print one of these out and see if it actually works. This thing uses like 10 screws to hold it together. But it's designed in the same principle as my other one. I'm very scared about this gap. If this gap fails, then it's GG. In fact, I'm going to go ahead and make this like 1 millimeter lower, just to make sure it doesn't collide. Because I know the screws don't like to go in sometimes. It's going to be a very close fit. And then I can just go ahead and... This is one modular wheel. I go ahead and get the chassis out. And then I go ahead and... Not the chassis, the chamber. Terminologies here. What happened to my joints? Oh. Wait, is this part of the chamber? What's going on here? Why isn't it letting me do this? Why did it like blink out? Modular. How did it blink that one out? Modular support wheel. Wheel holder's grounded, that's why. Unground. Okay. That's one. And I'm going to replicate it twice more, one time in the middle and one time at the end. make 3. Or I wonder if 2 is enough to carry this entire thing. Maybe 2 is enough. Because if this is allowed to rotate, then it should correct for any errors. Maybe. So this is going to be, I'm going to modular, I'm going to copy this. It's going to move it to the center. Or maybe just like move it all the way up here. Yeah, maybe that instead. Yeah. And I'm gonna have to modify the spacings on that so it fits. Okay. I'm gonna do it. I'm still thinking if I would need 3 or 2. Alright, I'll see you later, Bellum. Thanks for coming. I might end soon, too, since I already completed my goal for the day. I might do 3. Let's have this, rolling along the track. But thanks for coming, Bellum. I'll see you later. See you tomorrow. Bye-bye. I think I'm gonna put 3 on there then. 98. Split. 12.56 millimeters. You know what? That's close enough. Depth complete. Alright, now let's make these wheels golden and shiny and all that. Gold-plated axis, and then maybe a bronze finish on the bottom. Awesome. Let's see what it looks like when it's rendered. Oh, this is gonna lag the stream, I'm sorry. It's going to require a lot of screws to assemble. Okay. So these three sets of wheels are able to swivel. And then they are controlled by the thing in the back. Let's go ahead and make the... it's probably the last thing of the day. And then we'll call it a day for this one, and then tomorrow work on the actual chamber. And I think tomorrow will be the last step in completing this project, or this part of the project. Which is exciting. Actually, let me go ahead and edit the text. So what will the final product do? It's a fancy storage container for these 4S LiPo batteries. It's for storage, and then also data finding, and also a way to make it easier to remove and charge these batteries just using a robotic arm, which does not have enough force or precision to actually connect these XT60 connectors, which is what is usually used to connect these batteries. I originally wanted this to store 8 batteries, which I think it will. And so it will store the batteries. Another part of the team is working on the electronics and data retrieval part of it. We'll get all the data going into a Raspberry Pi, port it to a central database, which will be in the cloud, and then shown on a user interface. So then we can monitor the state of each battery, what it's doing, and we can remove it at any time using automation. And so everything here is just for one battery. But the great thing about engineering is you can copy and paste sometimes. So once you get something working, all you need to do is Control-C, Control-V, and let the computer do the rest. That is not centered. Wait, why is that centered? That does not look centered to me. Maybe it's too late to the night. I can't tell what's centered and what's not anymore. Also, this dark black area is not treating me well. 9.75. It is centered. Okay. Like me to judge what's centered and what's not, apparently. Alright, so for the finale, I'm going to have a bunch of screws all neatly aligned in an array, connecting themselves to a central arm that will rotate the batteries around. So yeah. So point in the center, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so these 10 holes will facilitate the grabbing of the arm. I think I can make it 5 millimeters deep. Even 6. Because this has to be a really strong point. Yeah. So this is going to be attached to an arm through the back. I'm actually going to space these out a little bit more. Like 12. Yeah, that looks better. Okay, so something's going to be able to screw onto this portion of it, and then there'll be an arm connecting to the front of it, and the rest will come tomorrow because I'm too tired to think about this right now. But hopefully these are able to print. From experience, I can say that they'll probably be able to. The design has been improved a lot, so these aren't going to fall off ever. I think when I initially did Hyperloop, this one, although it looks cool, I think it's going to fall off eventually. These are not the most stable forms of connections with the Trek. But these are. So, battery comes in and out. AR tank reads. You've got solenoids, which I still have to fine-tune the tolerances on. Electronics in the back. Wheels on the bottom. I need to modify the top and add like a line of screws so that it's able to be picked up by a drone or attached to one of those devices. Maybe just add some screws on the side over here, maybe over here, maybe on the top, and then it'll be good. And then this can be attached to the drone or as a part of the ground station. Okay, I think that's enough for today. Took me 2 hours to do all that. Let me go ahead and put a check mark next to add modular support, and then add bearing support. And then I have 4 things left, which is to create the rotational holder, add multiplexing support, test motor tolerances, render design. which can be done tomorrow. So I'll reserve that then. Alright, so I think that's it for today. Thank you guys so much for watching. We'll head over to... what do you want to head over to? I don't know. No one's online for me to raid right now. So I think I'm just gonna go ahead and host Maker Deck again, because Maker Deck is cool. Thanks, it's informational. No problem. Yoshi eats cookies. Alright. Well, thank you so much for coming to the stream today. I really appreciate you. I hope you have a great rest of your day, and then I'll see you later. Alright, I'll see you tomorrow. Bye for now!